Afternoon, everyone. Before we start, I have a question for all of you. Just that our practical class should be in week 4, 5, 7, and 9. One moment, let me share my screen. So our practical class should be in week 4, 5, 7, and 9, which has 4 class, each class 2 hours. So since we have a big class, I would say this is a big class, but just 30. So we will separate into 2 different groups, 16 and 14. But for your information, the practical class would be online throughout the entire semester. The previous selections for face-to-face and also the tutorial would be, face-to-face and online, face-to-face and online should be for lecture and tutorial only, okay? So practical would be based on the lecture. So for this one, because we are using MATLAB only, can I know any of you do not have MATLAB with you? Maybe you can use the put in maybe 1 in the chat box to acknowledge me. Any of you do not have MATLAB with you? The only software we use would be MATLAB. What version also okay? As long as you got MATLAB, then should be no issue. On the count of 3, need to reinstall should be no problem. Okay, perhaps you confirm first. Log in now. You confirm first. Is it okay for you to install? But make sure you install everything before week 3. At least week 3 lah. Okay. Please don't install during my class. EC, you don't have MATLAB. So would you mind to turn on your mic to, at least communicate, do you have MATLAB with you? If you don't have, do you need to use the lab? The main purpose for me to ask is that I found that, since we are used, the main purpose of this, the faculty to arrange you all into two different groups is because of social distancing. Because the lab cannot accommodate 30 students in one lab or one tutorial class, and so forth. So that is why it's separate into 2 different groups. But since the practical class is only online and you all don't need to, come to the lab, so I don't think we need to separate into 2 different sections. So because basically I just, repeat the same thing. So basically, if you all okay, so I wish to combine the class for practical only okay, for practical. So I wish to get the opinion from you all. Of course, the main priority would be if any of you do not have MATLAB, then perhaps you need to come to labs. Anyhow, if you come to lab, you can come to lab, no, never mind. I have to notify the technicians to let you all use the lab. But in fact, we are going for online class. So please let me know who would, need the lab because you don't have the MATLAB with you. Please let me know. Perhaps Chie, can you help me to collect this one? Collect this info. How many students and who will need the lab? Without the MATLAB with you, okay?
Sure. Okay.
And also, I want to know, since all of you already here, I want to know if anyone reject the idea of combining the practical class, which means 30 students in one class. Basically, the class would be, the flow of the practical class would be, I explain the lab manual and also the assignment. Then after explain, then you all will do the lab Okay, basically it's like that Of course, I will guide you all, but I will not guide line by lines. But if you required such a help, perhaps I can help. And yeah, something like that. So Isi, can I know you don't have any MATLAB with you, or you need to use the lab, or will you set it on your own? I wish to know, sir. I will reinstall. Oh, okay. Okay. So if you have any need to use the lab, please let me know earlier, best before week 3, so that I can arrange accordingly. Because if I did not notify the lab technicians, and perhaps only 1 or 2 people enter the laboratory, perhaps you will face a lot of questions. Maybe the lab assistant will ask a lot of things. So in order to avoid all these kind of issue, so perhaps let me know earlier, I will let the lab technician know. Okay, so but anyhow, the practical would be online. Okay, so either way, Tuesday, 8:30 to 10:30, 1 to 3. Can I know who select? Wow, you ask like this. Which time slot you all prefer? 8:30, morning or the noon sections? Noon, noon. Pool, yeah, good idea. Pool. Let me see how should I create a pool. One moment. Start the poll question, morning or noon. Option 1, morning. Option 2, noon. Lot. Okay, so go and vote for it now. Can you all see the pool? Okay, I suppose. Okay. I will base on the, of course, I will check the majority and I will seek the opinion from the minority. Okay. So, yeah, maybe spare you all 2 minutes to complete the pool. Whoever did not complete the pool within the time frame, I would consider you all give up. Yes, Jingwen.
Sir, can you show the time again? I just need to check my timetable.
All right, one moment.
Yep.
So it would be Tuesday, week 4, 5, 7, and 9. Tuesday, 8:30 to 10:30. And the other one is 1 to 3. So far, I think only the majority is known, and 18 woods plus 5 more. 23 only. Yeah, take your time. I put the time frame in the chat box instead. Okay, so far we have 27 wood, 20 for wood for afternoon, and 7 wood for morning. 3 did not wood. Okay, so can I ask the 7 woods for morning section? Is it because clash with the clash with the timetable with other class or whatever reason? Any reply from the 7 people? So is it okay for me to conduct only one lab, which is in the known? Tuesday, week 4, 5, 7, and 9. Tuesday, 1 to 3 p.m. Is it all right? Okay. So on the count of 3, if you not agree, please raise up now. If you need more time to consider, raise now as well. Yeah, on the count of 3, 3, 2, 1. Okay. So since no objections, of course, I already asked the consent from the 7 people, and yeah, no reply from these 7 people, and also the 3 votes. I mean, 3 people without voting anything. So I suppose I collect consents from all of you. So I will carry out the lab on one moment. Week 4, 5, 7. Week 4, 5, 7, 9, Tuesday 1 to 3 p.m. Okay. So anything regarding the lecture and the lab, since I mean the class joined together for practical class as well. So I will communicate with you all using the lecture classroom. Okay. For your information, you got 2 different classroom for this not MTAA. The first one would be the lecture classroom. The second would be your tutorial classroom. Initially, the tutorial classroom will disassemble the information regarding tutorial and also the lab. But since the lab is now combined, so I will disassemble the information regarding the lecture notes in the lecture notes Google Classroom and also the practical in the lecture notes Google Classroom as well. So I will make a small amendments in the announcement later on. Don't worry about that. So again, we will have our lab in week 4, 5, 7, and 9, Tuesday 1 to 3 p.m. Okay, for both the class, both the groups, which means we have 30 students in this lab. And whoever require to use the lab, please let Chia know, and I will collect this information from Chia by perhaps week 3 lah. Okay. And again, for your information, we have 4 labs here, which is week 4, 5, 7, and 9. So let me think. I think I will release the lab report to all of you on week 4 and the assignment perhaps on week 5 or 6. Okay, so the submission should be in lab report should be in week 10 and the assignment should be in week 11. Okay, so I will post all this information in the classroom later on. Don't worry about that. Okay, so any more questions regarding the amendments? No, if no, then I will start the lecture today. Okay. All right, I believe you all can see my screen. Since we have hybrid class, I mean for the lecture and also tutorial in the, I mean after week starting, yeah, okay, good. Okay, starting from week 5. Because to be frank, I'm not really sure how is the setting in the classroom. So in order to accommodate effectively both the face-to-face and also online class, so I think I will still present at the classroom as per the timetable. I will present over there because some of you opt for face-to-face and some of you opt for online. So either way, we will still I mean, carry out the class and also the tutorial in hybrid mode. Okay, But in order to accommodate both, I think I will not use the whiteboard to write anything, because I'm not sure if, I'm not sure whatever I write in a whiteboard, is it, reflective, this and that issue, causing those that attend the online class not able to see the writing accordingly. So the best I would be I continue writing using the pad, and then whatever I teach will be record, and yeah, same as now lah. Okay, but for those students that attend face to face, perhaps you can ask, you can feel like university, something like that. Okay. Any question, please ask. Do interrupt me. You're welcome. Okay, let us continue. In the previous lecture, we talked until I think somewhere around here. Okay, but let me give you a recap. So for this chapter, we are going to talk about the color model, because in chapter 1 we learn about the uh, fundamental in multimedia, which is from a very general perspective. What is multimedia, linear and nonlinear, multimedia and hypermedia, the continuous and discrete media, and sensitive and serif, something like that. So that would be a very general terms of multimedia. Will be very brief, and most of it is sort of common sense. Okay. Then later on in chapter 2, we start the introduction regarding the image processing. Not really the image processing, but we start talking about the image, the file size. Still in general, we talk about the file size for image, perhaps how many bit, grayscale we have 8-bit, for color map 8-bit, and also the true color we have 24 bits. We introduce you all regarding the RGB model. What is RGB, red, green, and blue, and how is the color intensity being formed, 0 to 255, and how to calculate the image size or the file size, specifically in image size for the chapter 2. The resolutions, whatever, what else? Let me think, yeah, something like that. Okay, in chapter 3, we will learn about the color model, more specifically in RGB. Okay, RGB, I should not use the word RGB actually. Perhaps I should use the word color model or color scheme, because RGB is one of the color model. Because in color model, we have different example. Because in this, we have different example. For example, we have RGB. RGB is one of the cliche example for color model. We have HSI, HSV. We also have CMY, and later on we have K. We have CBR. We have many more lah. Okay, we have many more, which is sometimes is not so common as well. Okay. So color model is, in this course, I would prefer the word color model, because as compared to color scheme, color space and etc. Sometimes the color model is much more common to the society. So I prefer the word color model, but anyhow, if you use other synonym, is fine. Okay, not an issue. Okay, so color can be defined by choosing 3 primary color, which is the red, green, and blue. And this would be the intensity in red, intensity in green, and intensity in blue. Of course, this equation, as I mentioned before, it is meant to be, add up together, maybe 200, 100, 100. It's not meant to be 400, but it is meant to overlap or superimpose the images, one slide, 2, slide 3, and combine together to form a color. Because it is meant to combine the intensity in red, green, and blue to form different color. For example, any color, should be any color, because by calculating the possibility, 256 times 256 times 256, you will get sort of 60 million color. So by varying the intensity from 0 to 255, in total 256 different intensity for three different layers, perhaps you can create 60 million different kind of color. Perhaps, red, there is a lot of different red. So basically, usually they will use the color code to define a specific color. For example, when you go to buy the paint to paint your house, for New Year or whatsoever, usually the paint will it has its very own code. So you don't tell the shop, the seller that, oh, I want blue color. What blue you want? So perhaps it has a specific code. Okay, you can find the code from the catalog, and perhaps for some industry they are not using a specific code. They have their very own code. For example, um, R1, R2, something like that. Okay, because sometimes they don't want to let people know this code is referring to what color. Okay, they have their special skill to mix the color and form this, for example, metallic blue, something like that. They have their very own recipe. So color model, color space, and color system, and also color scheme provide standard approach to define color. So these are the standard perhaps to define the color, because we cannot tell people red, how red is red, how blue is blue, and so on. So we need to give an accurate, this red is with intensity 200, 100, and 100, something like that. So this should be sort of maybe moderate red, something like that. If the red is something like that. Okay, it provides a coordinate systems where each color is defined by three tuplets number. Gamut is the range of color that can be produced by the color model or generated by a specific device. So it's describe the range of color that can be produced by combining a set of primary color. Primary color is a key terms whereby the primary color is referring to RGB. Secondary color is referring to CMYK. How is this being formed? We shall look into the Cartesian plan, the 3D Cartesian plan. Okay, RGB is the primary value at three corner, and see a secondary color, which is CMY, at the three others corner. So you have different exits, X exit, Y exit, and Z exit. So you have red, green, and blue. Either way lah. Okay. Then when you mix together, of course, when I draw this chart, in order to simplify the chart, the graph, perhaps I will use the range between 0 and 1 after normalization. So let's say you have one here, which means you have 1, 1, and 0. So you will get another point here. And let's say you continue for the other possibility here. So you can actually draw a box, something like that. Okay. So whenever everything is 1, which means you have one green color, one red color, and one blue color, perhaps the point is here. Imagine it. So 1 is actually equivalent to white color. Okay, it's equivalent to 255 255 and 255. So K is the original. Always remember, 0 is always black color. Okay, 0, 0, 0. Okay, so this is black color, and when you have 0, 0, 0, for sure the point is located at the origin. So this is the overlap of the primary. Not really overlap but the color, the gamut for primary and also secondary. So this is the primary color, and this is the secondary color. When you have everything combined together, you have white color. Okay, when you have nothing, so you will have black color. So this is the three different axes that I mentioned just now, and I already showed you all last week. Should be, not last week, previous lecture, should be no issue. So everything travel between the white and the black, which is the original. This is 1, 1, and 1. So all the value lie within this line would be grayscale. Okay, grayscale which means this same number of color lah. Okay, you can plot this graph very easy. For example, you have 200, 200, and 200. So oh, we cannot use 200. Maybe we have 0.8, 0.8, and 0.8. So let's assume 0.8 is located somewhere around here, around here, around here, and around here. So when you plot the graph, you will get somewhere around here lah. Okay, since this is 1, 1, 1, this is 0, 0, 0. So your graph, because all these three exits, the point move in the same direction with same scale. So for sure, it will move outward or downwards according to this line lah. Okay. Because it is directly proportional. Okay, so I believe you're all quite familiar with this. During primary school, the only thing we play in the computer lab would be the paint. Okay, so of course, your generation is different from mine. Perhaps last time in our computer lab back to primary school, we only have paint. So I also don't know what we are doing over there. Just play around with the paint. So yeah, I'm very familiar with this one during the primary school. So we play around, to tune the color, etc. So basically, this is the color model over there. So over here, we are using HSL, hue, saturation, and illuminations. Sometimes they will change with HSI because sometimes illuminations and intensity is interchangeable. So sometimes they will use HSV or HSI. Okay, sorry, HSL. Okay, for color formations, there are two methods of color formation in productions. Production is actually a key terms, not really a key terms, but a very common words used in engineering. I think you all did an intern before, right? I'm not sure if you did join any industry with production line. So the production line is actually a space or a compartment where they manufacture their product. Okay, we call it as production line, and yeah, the production line would be very tight schedule. And when we take the semiconductor industry as the production line, taking the semiconductor industry as the example, the production line could be start with cutting the copper, heating the copper, cutting it into small pieces, different die size, and then you fabricate the copper to form a specific die, use the laser to craft the matrix code, to craft the orientation pin and etc. And then pass to another sections, which is, one machine for after done this process to another machine, and so forth. So the production line usually is very long. So when you pass by, I'm not really sure KL, but when we talk about Penang, especially Batu Kawan, you can see the industrial, why it is very, very big, very long, like the Boston Scientific. It is very big, very long. So they has their very own production line. And usually the production line is in a line. Not really a line over there, but, a big compartment, which they try to maximize the production and minimize the time taken and cost. Okay, so same things to Inari, Vitrox, and etc. They have their production line. Of course, different industry would have so-called different product. So their production line is not a machine based. Let's say you have maybe the family mart, they have their production line as well to package the food and etc. So their production line would be sort of more to food manufacturing lah. Okay. So in these terms, in the production, which means it depends on the applications. Let's say we have printing industry, because I think printing industry is the one who has close relations with color and images, especially the printing industry for magazine and etc. So we have two different type of mixing: additive mixing and subtractive mixing. So as per the words, um, additive mixing, which means you add something together, A plus B plus C, and subtractive would be minus something from something else. For example, you minus something from white color and etc. Okay, so you have two types of mixing, which is additive and subtractive. So the example of color model that use the above mention of color mixing are RGB and CMY. So RGB is for additive, CMY is for subtractive. So the application would be monitor and also printing. As I mentioned before, all these kind are quite common in multimedia. So perhaps you need to know. I will not say you need to memorize because I never memorize a human got how many eyes, how many nose, and etc. So I don't think you need to memorize all this. But perhaps you need to know at least. At least you won't be surprised when you saw human got two eyes and etc. Okay. So it's the same thing. When we talk about monitor or the digital display, perhaps the main color model we are using would be RGB. And in printing industry, we are using CMYK. Okay. So for additive mixing of primary color and subtractive mixing of the color pigment. So basically, in order to get the magenta, you can actually add red and blue to get the cyan, blue and green, to get the yellow, green and red. So this is exactly the same to this chart. It's exactly the same to this chart. When you have one red and one blue, you will get magenta. When you have one blue and one green, you will get cyan. So it is the same. Okay, red and blue, magenta, blue and green, cyan, green and red become yellow. So it is using the plus sign. And for the subtractive, we are going to subtract something else from the whole. The whole here would be the white color, because white color is when you have R, G, and B, 1, 1, and 1. So supposedly you are everything. So we will call it as a whole lah. Okay. So the white color will be the main color. So after you subtract something else from the whole, the white color, so you will get the remaining. Let's say you have R, G, and B, 1, 1, and 1, which is white color. And after that, you subtract away blue color. So you suppose you to have 1, 1, and 0, right? So what color is it? What color is it? You can put it in the chat box. Do you understand what I mean? Sometimes I'm not sure if you understand. Okay. I'm not teaching myself. Okay, if you don't understand, please let me know. Okay. It's okay to interrupt me. So again, let me explain. So you have red, green, and blue, right? Let me back to this one. The additive. Okay, so magenta is equivalent to red plus blue, right? So which means you have one for red, one for blue, and green is 0. I put it in this way. GB. This is 0, this is 1. So when you combine this one, actually you can ignore this one, right? So magenta is equivalent to red plus blue. Okay, so let's say you have a white color. White color. Still remember, white color consists of what? Consists of R, G, and B. Everything in max, right? Or 255, 255, and 255. Is it correct? So if you minus something else from the white color, let's say you minus away, you remove the green color. Okay, so what else you have? You have R plus B, right? Blue, right? So R plus blue, red plus blue is equivalent to magenta as well. Can you understand? So which means when you, both methods can, able to get the magenta color, but different approach. Okay, which means you still can go to Thai by different methods, perhaps cycle, walk, taxi, grab, whatsoever, but with different methods. Okay, even you can take plane, whatsoever. Just that you are using different method to get the same thing. Okay, no matter maybe sometimes it's very tedious, the method used is inappropriate, but at last you're still able to get the same answer. Okay, so additive and subtractive would be the same thing. Just that additive is adding red and blue and you get magenta, but subtractive you will minus green color from white color. That's all. Okay. But if you ask me again, if you ask me which one is better, which one is simpler, which one is superior, I will not say any of it superior than the another one. That is because it is depends on the application. In some application, A might be superior, but in some application, B might be superior or more appropriate. Okay, so it is very depends on the on the applications. So make sure during the exam, if let's say such condition asking you maybe in da condition, what would you prefer? Justify your answer. So perhaps you need to look into the application and how the application being linked to your solutions. So you give justification accordingly. Okay, but of course, I would allocate more marks on the justification rather than the answer. Okay, for example, uh, why method A is suitable? No, should be in a conditions. Would you choose method A or method B? Justify your answer. Perhaps you give me method A, and then you did not give me any justification. No matter method A is the correct answer or the incorrect answer. Of course, if it is incorrect answer, you will get zero lah. But if it is a correct answer and you just give me the answer alone without any justifications, I suppose you will only get 1 mark. Okay, 1 mark for the correct answer. Because the correct answer is not everything, but the reasoning behind the correct answer is a major part. I will not say everything lah, okay, but a major part. Okay. Okay, let us continue. Additive mixing. Primary color, red, green, and blue. So as I mentioned before, primary color is related to additive mixing and also related to, the applications is in monitor or digital display. And the 3 primary color used to produce other color. So most of the color is in the visible spectrum can be created by mixing these 3 primary color. This is called additive property, color property, and it works by mixing the primary color from emitting light. So example, mixing red and green yields yellow. When RG and B color are all mixed in a certain proportion, a wide range of color can be created. Basically, you can actually calculate the number of the probability that the color range you can by using this one just now I mentioned 256 and 256 and 256 because you have range from 0 to 255 in the first layer, the same thing in the second layer, and the third thing in the third layer. Okay, I believe this is sort of, is it called permutations or probability? I forgot what it means, but I think we do learn this in back to form 4 or form 5. Okay. So the merging of lights emits from the color light source is an additive process. Basically, if you have a red color ray and combine with the green color ray, you can get something else. Okay, this is what we call by additive. So all spectral color and white color can be created by adding red, green, and blue together in a certain proportion, of course. Okay. In order to get different color, basically you will need to control the intensity for each ray. So applications to produce color image in color TV CRT. So this is CRT, cathode ray tube. Of course, I don't think now you have this one because last time I'm not sure if you all still able to. Oh, this is, yeah. Last time the TV is look like this one. I'm not sure if you all know. I think your generation, the TV is quite thin, slim. Okay. because it is a different method to display. But last time we have a TV console, and then the TV console is usually very big. It's because the TV, this is from the side view. It's because the TV is very big. Okay, the cathode ray tube is behind it. Okay, the cathode ray tube is very sensitive. So that is why when you drop the TV, usually the cathode ray tube inside will broken and habis. Okay. One moment, I answer call. Okay, sorry for that. Let's continue. Okay, that is what we call by additive lah. Basically, it has three different guns here, and each guns, admit different, red, green, and blue color, and combine red, green, and blue color atoms or beams in a specific proportion and display a specific color. Okay, that is how the color TV being displayed in the old glory time. Okay, subtractive mixing. The number specify how much of certain primary color to be removed in order to obtain the desired color. So cyan, magenta, and yellow are the three subtractive primary color. So again, the color model here in should be CMY. You seldom can, when you search for Google using the search engine, it's not really you can search for CMYK lah. Okay, the reason why is that K is an additional color ink that is add into the color model CMY. Okay, and because as I aforementioned, the CMY would be the color model used in the printing industry. So the printing industry require a lot of printing using black color ink, no matter the fonts, the heading, the outline of a graphics or a chart. They always use the black color. But when in real life applications, uh, reducing, assigning the intensity 0, 0, 0 for CMY, we're supposed to get a black color. But nevertheless, when we have 0, 0, 0 value for CMY, we cannot get a pure black color. So that is why afterward, a K, which is black color, is being added to the CMY color model, especially for the printing industry. Okay, this is because it's make the entire process much more simpler lah. You don't need to do mixing for something else where you need to use very, very frequent. Okay, so the CMY is referring to cyan, magenta, and yellow are three subtractive primary color. So you have to know when we talk about the additive, we have different primary color. Okay, but like uh, the main character for additive mixing would be the main character in additive mixing would be RGB. The main character in subtractive mixing would be CMY. Okay, so do not confuse both of it. So the color coordinate D would be C, M, and Y. Usually they will arrange in this way. They will not put Y, CM, no. They will not put it in this way. Always CMY or RGB. Follow the sequence from left to right. Okay. Specify the proportion of cyan, magenta, and yellow color pigment to be mixed to produce the desired color. So cyan pigment absorb red color, magenta absorb green color, and yellow absorb blue color from white color. Okay, so in previous additive, we are actually mixing, like we have different electron guns, and then with different electron beam, and this beam A and beam R and beam G mixed together to form some color and etc. But in subtractive mixing, the subtractive mixing cyan, magenta and yellow is not combining to form something else, but rather they try to absorb some things from the white light to form another color. Okay, so the color coordinate D is equivalent to CMY. Also specify the amount of red, C amount of red, M amount of green, and Y amount of blue. That is because cyan channel is actually absorb red color, magenta is actually absorb green color, and yellow is actually absorb blue color. Okay. So subtractive color mixing is based on reflective color rather than emissive color. Reflective color refer to the color from light reflected from a surface into the eye, used primarily in the printing industry. By printing the three subtractive color in different proportion on white paper. Okay, because you have white paper lah. So that is why when you use different paper, different color paper, it may result in different color. Okay. So cyan, magenta, and yellow. This graphic is a bit different from the previous one where the RGB is, when the RGB is located at these three corners, but magenta, yellow, and cyan is overlapping. Is because it's meant to talk. It meant to talk about the subtractive color. Okay, so it depends on which field. For example, I'm not good in badminton, but you are very good. So during badminton court, perhaps you will dominate the entire field. But during another sport, maybe I will dominate, something like that. Okay. So for the subtractive, the primary color would be yellow, cyan, and magenta. And for the additive, the primary color would be RG and B. Okay. So make sure in which context you are talking when you want to give an answer. Okay. So cyan, magenta, and yellow filter or pigment subtract varying quantities of red, green, and blue from white light to produce a limited gamut of spectral color. So the core difference between the subtractive and additive is that additive is actually add on A plus B, but subtractive is absorb minus absorb or minus something else from the light source, or from the white light to be specific. Okay, so this is how the difference between additive and subtractive. So halftone color printing normally employ 4 overlapping grid of dot CMYK, which subtract different amount of RG and B in the proportion of with dot size. Okay, this is just for your information. Okay, color model on image. Each color model use 3 primary color. The coordinate system describe the mixture of the primary color. Coordinate system is actually the one G and B. Either way lah, it's not a must to write in this way lah. Maybe you want to put it, R, G, and B. The same chart is still valid lah. Okay, just that the point is different. Depends on the location of red, green, and blue. So color model are commonly used in RGB, used in image capture and image display, basically involving the digital monitor or any digital display. So perhaps we will use RGB, CMY or CMYK used in color printing, HSL, HSV, and HSI used to represent color in computer graphic, easy to be manipulated. So RGB, in the subsequent slide, I will, introduce more on the different of these color model. But of course, there are numerous of color model outside there. So if you, we are not going to look into each and every one, but we will look into those which is very common to image processing, commonly used, I would say, because some is not really commonly used. So for those, you may want to get extra information from the any public search engine. So based on additive mixing of three emitted light source, you can form RGB. So color is represented by a numeric triplet specifying R, G, and B value. The R, G, and B value is between 0 and 1. This is true when you normalize it, okay, which is from 0 to 1. Okay, if you without normalization, it will be 0 to 255. Okay, how to do normalization? Basically, you just divide the intensity, let's say 202 divided by 255, so you will get your value. Okay, as 0 divided by 0, 0 divided by 255 will be 0, right? And 255 divided by 255, you will get 1. So this is how you normalize into range 0 and 1. Okay. It specifies how to mix the three primary color, red, green, and blue, to produce various color. The RGB numeric values can be easily mapped to voltage for the R, G, and B electrode gun. This is meant for the TV productions, TV production line, where you need to combine the electron guns, um, to emit the electron beam to form different color. So coordinate system for RGB color scheme, this is same as what I mentioned before. So perhaps no need to mention. So some color cannot be synthesis because this will require the R value to be negative. The range of color or gamut that can be produced by RGB's color model is smaller than the hue. It's smaller than human visible color. So basically, RGB in 0 will be black color, ideally, okay, and RGB in 1 will be white color. CMY, based on the subtractive mixing, use the property of ink to absorb certain color. So basically, absorbing is what we're referring by subtractive, okay, because you absorb something from the whole, which means, for example, what color you absorb over red color. So you will left out green and blue, okay? Instead of color addition, color subtraction is done. For example, yellow ink subtract blue from white illuminations but reflect red and green, which is why appear as yellow, okay? Because red plus green would be yellow. You can refer to this one. Red plus green, this one, you will get yellow, because it's absorbed away the blue color. So CMY, cyan, magenta, yellow, and black. Why we call it as black? It's because you cannot use B because B is actually blue So later on we assign it as a K to represent the blue color. It's widely used for color printing. When we invert the specific what ink density to lay down on the paper to make a certain desired RGB, the conversion between the RGB and CMY can be done by using the following equations, perhaps. The matrix now, okay. Basically, um, in image processing, basically we are actually dealing with matrix. Since you have array, the 2D image itself is an array. So basically, when you are dealing with the image processing, you are computing or calculating the metrics. Okay, we have more about the metric calculation later on. Okay, especially during morphological operations, maybe Laplacians, maybe a median, Gaussians, all those. Okay, so basically, you can see this as a 3 times 1, 3 times 1, 3 times 1, or 3 times 1 metric. Okay, you have 3 different row and 1 column. Like that. Okay, so basically, this is sort of mathematical calculation as well, but in terms of metrics. Okay, so CMY would be why this is 1, 1, 1, because we always absorb or minus something else from the white light. The white is represented by 1, 1, and 1, right? So yeah. So that is why we put it as 1, 1, 1, okay, by default. And it is actually referring to white color. And RGB, will be the reflecting color, and whatever is this is the ink pigment. Then the inverse formula would be Rgb is equivalent to this one. Okay, basically, some mathematics, move this over here and move this over here, so you will get something like this one. So effect of the color ink. So let's say you have an incident like a white light coming in, a layer of cyan ink on the surface, absorption of red color. So which means the white light here you have R, G, and B, right? Okay, you have a cyan here. Cyan is what? CMY. Always remember this model. So you have 1 here, 0, 0. Because this is only pure cyan, because it's mentioned cyan only, right? So cyan, this is CMY. So suppose you have 1, 0, 0, don't have any magenta, don't have any yellow. Okay. So 1, 1, 1 minus by 1, 0, 0. You will get this one minus this one, you will get 0, 1 minus 0 等于 1, 1 minus 0等于 1. Okay, correct. It's like that. So it is equivalent to 0, 1, 1. So basically, this one, okay? This is the final answer. But of course, in the exam, you don't give me 0, 1, 1. End up, you have to answer the question. For example, you give me what color is it? Okay, so green and blue plus is what color? Okay, something like that. Yeah. Okay. So basically, you don't need to draw this one, okay? Just for your information. I mean, just to explain to you all. So basically, red, green, and blue. This is the white light from here, and this is the absorptions of this color pigment. Okay. After first of all, you need to calculate. I mean, not really calculate that, but jot down what is the absorption ink here. So since this is a cyan ink, so CMY. So you will become 1, 0, 0. Okay, so simple mathematics, 1 minus by 1 is 0, 1 minus by 0, 1, and continue. Okay, so this is this is how the printing being done and how the subtractive mixing is being conducted. Okay, the same thing here. Let's say you have different layer, and of course this is still true, remain true when you have more and more layer. Okay, but for this case, you have one layer of cyan, one layer of magenta, and then you have incident light, white light. Okay, always remember incident white light is 111, and magenta CMY, so it's 0, 1, 0. CMY, cyan 100. Okay, so after minus this one, so just simple mathematics. Rgb, the white light 111 minus first layer, second layer. So 0, 1, 0, 1, 0, 0. Okay, and then just do the simple mathematics lah. You will get this one. Okay, so this would be the color. Either way, you can put it combined together. It's okay lah. But you don't give me, you don't just draw me this one lah. Okay, if you draw me, if you give the solution only this one, I worry I'm afraid I cannot give you full marks. Okay, because I'm not sure if you are, copying from someone else or whatever. But for your information, I believe you're all aware. For this semester, your examination will be face to face. Okay, so no more open books, and it is face to face. Okay, so basically, whatever I mentioned just now, using these equations, it is meant to convert between the Rgb and CMY interchange lah. Okay, but of course when you're using MATLAB to perform the image processing, it has its very own let me think, I'm not sure is this still valid. Rgb to CMY, Rgb to HSI, I'm not sure is this code still available. One moment, maybe let me check. Rgb to HSI. Oh yeah. Oh no. Oh, I think don't have by default. By default don't have this code already. Perhaps if you want to convert this one, I mean, for your maybe FYP or maybe practical later on, perhaps you need to I mean write in this equation on your own lah. Okay, maybe the latest version should have conversions. I'm not sure. So as cyan, magenta, and yellow CMY are mixed, then all the RGB color are subtracted and the black color is obtained. Okay. So basically this is what I mentioned just now lah. However, in practice, the ink are not pure, hence a special black ink kit is used. So this is what I mentioned before, where you don't want to, I mean, incorporate or printing something is not pure because in real case, I mean, in real world, the the mixing of the ink is actually not pure. Why we did not aware of this for others color because we don't really have a choice. It's not possible for you to add in 60 million color individually. So end up based on simplicity, we will still use the mixing of RGB or even CMY. Okay, but for black color, it is very common to be used. So it's important for us to incorporate, I mean, add in a special ink just for the printing industry. So HSI, HSI is referring to hue, saturation, and intensity, picking up the first alphabet of hue, saturation, and intensity. So you will have HSI. So for HSV, hue, saturation, and value, and HSL, hue, saturation, and lightness. Other lightness and illumination is the same. Just that sometimes they use different words to represent the alphabet. But actually, HSI, HSV, and HSL, it is identical but not same. Okay, I use the word identical because they are really, I mean, looks alike lah. Eventually, uh, the cylinder cone coordinate is more or less okay. Are three most common cylindrical coordinate representation of point in RGB color model. So HSI, HSV, and HSL representations rearrange the geometric of red, green, and blue in an attempt to be more intuitive and perceptually relevant. So the representation of HSI, HSV, and HSL are very similar, but not completely identical. So express color in a way that is similar to how human describe color. Although the RGB, the CMY is used in digital monitor, used in printing industry, but nevertheless, the way human eye prescribed color is a bit different from RGB and CMY. So HSI, HSV, and HSL would be I mean, closer to whatever we see. Okay, but if you want to know in details, what is actually the difference between HSI, HSV, HSL in conjunction to the red, green, blue, and also the CMY? Perhaps you need to read other article paper to understand. Of course, the first thing is the plotting of the color model is different already. Okay, but then I would say both. I mean, all of these has a close relationship. So HSI's color are represented by a triplet representing hue, saturation, or chroma, and I, which is the brightness. Okay, um, hue is the dominant color of a sample and is represented by an angular value varying from red to blue and magenta, ranges from 0 to 360. What is 0 to 360? Because it is about the angles, like something like this, a pi, okay, a coordinate. So start from 0 to 360 degree, okay. But in these terms, it's still using the words. I mean, it is not 0 to 255. but it is referring to a specific degree. Okay, this is actually referring to degree. How should I put it? Degree. Okay. But normalized to 0 to 1 in some application. Okay. Some application you may not see 0 to 360, but perhaps 0 to 1 because it's already being normalized by dividing 360. So saturations, purity of the color or hue range from 0 to 1. Brightness, luminance of the color range from 0 to 1 as well. So this is black, this is white color. So this is the example of HSI. So this is a triangle, which is this plate. So center point here, let us assume this is the 0 degree. So the degree is ranging from this point 0 to this point, which is 360. Okay, exactly like the pie, like the pie chart. Oh no, like a pie, 360 degree. Okay, something like that. Exactly the same. Just that the outer part is a triangle. Okay, so okay, this will be the original, and the way, I mean, the angle, the coordinate being moved is referring to the hue. Okay, and this one is the intensity, which range from 0 to 1. 0 is referring to black color, and 1 is referring to white color. Okay, and you have sort of this one 0.5, so the range of your color would be bigger, which is the biggest, I would say, the biggest, which is at this area. And for this one, the area distribution is a bit less, and it is more approaching to bright color because it is near to white color. And for this one, you will have the same size as this one. If the distance is remain the same. So you have a same size of the gamut as this one, but then the center point will be black color. This one will be black color instead of white. Okay, because when the color is approaching downwards, it is become darker and darker, and finally become black color. And you move outward, it will become brighter and brighter, and at last become white color. Okay, so this is the color model. I mean the what we call a cylindrical coordinate representation. This is another color model. Sometimes people interchange both of this one. And this one, it is, this is a triangle shape. But this one, it is a circular shape at the center. Okay, so the same thing, hue, intensity, and saturation. So this is referring to the saturation, which is 0 to 1. Okay, center point will be 0, the outer space will be 1. So if you have a point located here, so it will be very saturated. So if you have another point, maybe located here, it is less saturated. And if it's at the center point, it will become a white color, which means you have none of the saturation. For example, you have a red color. Let's say this is the origin, your plot over here. So as you can observe, when the color is approaching outer, the circumference of the circle, you will have a pure red color. When you're moving inside inner and inner part, your saturation will be changed, and until this one, it would be another different color. Okay, so this is the difference. And let's say you have a yellow color. So when you have saturation is equal to 1, so you will have a pure yellow. But if your saturation is equivalent to 0.5, this would be your color. And when your saturation is 0, then this would be your color, this one. Okay, so this is the effect of adjusting the eye intensity become white or black, adjusting the saturation become more saturated or less saturated, and adjusting the degree to select which color is it, because different degree is referring to different color. For example, you have 10 degree, perhaps you will get a red color. Perhaps if you have 180, you will get something like maroon, forest green, something like that, or perhaps blue. So that would be the difference for HSI, HSV, and HSL. So basically, if you for layman use to use HSI, HSV, and also HSL would be more or less lah. Okay, but it is more closely to what human prescribed color. So table below shows hue represented by color is angle from 0 to 360 degree. So 0 to 60, you will have red color, 60 to 120, you will have yellow, and so on, green, cyan, blue, and magenta. Okay, so basically you have the primary color and also the secondary color as well. But the way the color being represented is a bit different, okay, because it is using uh, the angle to represent it. Okay, so saturation increase to the right and intensity increase to the top. So this one is become higher and higher saturation. This one is become brighter or darker, something like that. So if let's say you have, this is why this one, it is a staircase like because it is actually mimicking this one. Okay, because this is why the staircase being formed because this is actually over here okay, either way, if this is circular or this is triangular, okay, and this is why the color is reducing okay, because when you have very high saturations, when you reduce this one, it will automatically go to this one, this one, this one, this one, this one, this one, and if you tune the intensity to the lowest, it will directly become black color. Okay, this is true and apply to every color. Maybe the highest saturation is yellow or magenta, is the same. So if you tune up the saturation to max, you will get this one. If you tune the saturation to lowest, you automatically get the white color. Okay. This is actually like a cross section for this part Okay. So this would be the low. This would be the high. This would be the high, and this would be the low. Okay. This is for I, and this is for S saturation. Okay. Any question regarding this one, or very confused, don't understand this and that? Any question from you all? None. Okay. If none, then we take 5 and then we continue. Okay, take 5. We will back here by 2:23. Okay, let us continue. So the HSI color model is a hexagon subset of cylindrical coordinate system. Basically, is exactly like what displays here and here lah. Okay. The eye can see about 128 different hue and about 130 different saturation. Because our eye, I mean, as a human eye, it is not ideally we can see all the color, but in fact we cannot. I mean, we would be more sensitive to certain color and insensitive to certain color. So that is why sometimes it is important to identify what color people are, I mean, human are more sensitive to, so that you can use that specific color in your advertisement, poster, and etc. effectively. Okay, all of this will affect can you draw the human, I mean the public uh, attention. Okay, so the hue HSI, HSV, or HSL color model is more likely to be related, I mean closely related to how human can see, what is more sensitive, what is insensitive to human eye. Okay, although it is not represent, I mean, in a full color spectrum as per the RGB or CMY, but it is more human eye friendly, maybe. About 120, human eye can see about 128 different hues and 130 different saturation. So easier to manipulate to make color softer and or reduce saturation value. So typically used in computer graphics. Okay, so typically a color image is represented as HSI when used for editing or human processing and convert to RGB when it is being displayed. So it has a different what we should call this equations for you to calculate. So it's important to remark when you have R prime, G prime, and B prime, it is different from RGB. RGB is referring to 0 to 255. But when you see the prime, it is 0 to 1. So make sure whenever you calculate this, you remember to convert, I mean, to more normalize it. If you without normalization, you will not get the correct answer. Because by adding 255, maybe 200, maybe 100 together, and divide by, I mean, 3 divided by this value, and 1 minus this one, for sure you will get the negative value lah. Okay, so make sure you do this accordingly lah. Remember to normalize it. Okay, so RGB is said to be so R prime, G prime, and B prime is the gamma corrected RGB. Basically, it is in mathematical terms, it is just normalization. So the gamma correction adjusts the overall brightness of the RGB by normalizing the pixel RGB color component from its current individual value of 0 through 255 to real number between 0.0 to 1.0. Okay, so basically this is just an example. I mean, red color is referring to 0, yellow is referring to 0.1667, and so forth. So typical color is, okay. So basically you need to calculate the H, S, and I. But in order to calculate the H, you need the data. The data is calculated by using this one. Okay. So the rest should be no issue lah. Okay, the RGB coordinate and the HSI coordinate, this would be the difference between these two coordinate, I mean the coordinate system. Of course, this is not only RGB, of course, including the CMY and K as well. Okay, but usually we call it a CMY only. And when you put it into different system, so you will have red, green, blue, C, M, and Y. Okay, and representing using different degree instead. This is representing 0 to 1, and this is representing 0 to 360 degree. Okay, but of course you can normalize it 0 to 1 is okay. You just simply divide by 360 degree. Okay, so you can normalize it 0.0 to 1.0. It's okay one. Okay, so just a circle like this one. So color model on video, method of dealing. We have learned, I mean, in the in previous section 3.3, we already learned color model in on image. So basically, it is regarding the image, how the color model is being put in an image. Uh, Actually, the color model in the video would be more or less lah. Okay, but then of course the color model in video sometimes is complying to different standard across different country. For example, in Europe, it has their different standard to display the video, different standard to display the, I mean, to play the moving graphic through the TV and etc. So perhaps in different region or different country, they will have different policy. Okay, method of dealing with, but in terms of image processing, if you want to process the color video, it is still the same as the uh, uh, image processing in image, because at the end of the day, the video is just a series of image arranged in a correct sequence. So when you pause the video, extract the frame by frame, and perform image processing on it, it is actually the same. I mean, the same methods is being used uh, in the image processing you can use to the video processing. But of course, if you one image alone, you need uh, high processing power. Perhaps when you deal with the video, you may need a better RAM or better processing power, or even eventually a better OS. Else, your computer may jam, may hang, and etc. So method of dealing with color in digital video is largely derived from older analog methods of coding color for TV. So color model used on video such as YUV, YIQ, YCBCR contain the luminance, brightness, and chrominance informations. So chrominance refers to difference between the given color in the television picture and a standard color of the same luminance. Luminance is actually referring to the brightness, like the saturation, like the intensity, like the brightness in the previous HSI, HSL system. So luminance is about the brightness. So the brighter it is, you will get a brighter red, brighter green, or brighter blue, something like that. But if you have a very low luminance, perhaps you will get a dark or dull uh, or a dark red color, blue color, and yellow, and so forth. So chrominance is referred to the difference in color. Most digital video use a matrix transform called YCBCR that is closely related to YUV 58. YUV 58 is a standard and NTSC, Nationalized Television Standard Committee, and PAL, phase alternating line are formats used for displaying video. So this format is like JPEG, MPEG, or those is a standard policy according to different country. So the main difference between two formats are based on their electrical difference, resolution quality, and rate at which the broadcasts are displayed. So electrical difference is very important because we have different countries, we have different electric consumption and also the electric supply. So for example, the electronic device that you use in, I believe you all been to some other country, let's say you have. So when you go to a different country, they will have different plug, right? And different plug, they will have not only different plug, I mean the input of the electricity, but also different power supply. So when you use when you buy an electronic device from other country, especially from not from the Asia region, perhaps you have to check the voltage, check the electrical supply, the watt, and etc. Because sometimes the electronics device is not able to support the power supply here in Malaysia. So whenever you plug in your device, you will causing some electrical issue lah. Okay, maybe your device burn, your fuse burn, and etc. So that would be the difference in electrical difference. I mean, difference in terms of the types of the color used in terms of televisions and of course the video lah. Okay, it's due. One of the reasons would be due to the electrical difference. So types of video, we have analog TV, we have digital TV. So the video format would be PAL, NTSC, and for the digital, we have CCIR and REC.601. And the color model here would be YUV, YIQ, YUV, YCBCR. Okay, now introduce a little bit in the different color model as this one. Don't worry, I don't think I will, I don't think I will ask what is the analog video format for analog TV, or what is the color model for digital TV. I will ask something like that lah. Okay, but it's good for you to know. At least this is a general knowledge lah. Okay. So YUV is the color format used by PAL, analog broadcast video standard. So PAL is actually the standard, the same to all these four lah. It is a sort of standard. YUV color model is represented by one component of luminance Y and two components of prominence. One component of luminance Y and two components of prominence UV. So Y is the luminance, UV is the chrominance. So as I mentioned before, the luminance is about providing the information in terms of brightness. But for chrominance, it is provide the information in terms of color. So YUV color model of video separate Rgb into luminance Y and chrominance U and V. So basically, no matter whatever the standard it is actually still using the, still using the same information as in the RGB, just that it convert to different standard. For example, it convert to YUV, YCBCR, and etc. It has a different standard, but the information still remain the same. Okay, so when you have RGB, you can actually convert to many different color model. Depends on your application, depends on your standard, and etc. Okay. So human eye is more sensitive toward Y, the luminance. Excuse me. So human eye is more sensitive towards Y, the chrominance, the luminance, than U and V, the chrominance. So in order to reduce the video size, the Y component can encode with higher resolution compared to U and V. We will learn this one later on, especially during the compressions method. Because we always want to, as I mentioned before, if you have a lot of different, since you have 2 car park and you have 5 car, perhaps either way, you need to buy more car park or you need to sell your car. Okay, either way. You cannot have 5 car park on the 2 car park. Okay, this is the same thing that happens here. So we try, if you have abundance of space, that is fine. You don't need to do any compression, it's also all right. But just that sometimes it's not so sustainable lah, because only one images that you snap, which is the image with not much meaning, but then the image occupy 5 gig, those that are using limited storage in your mobile phone or your electronic device, then you will truly understand, the urge when you have very limited space for you to use and you don't know which one to delete. Okay, so that is the importance of compressions. Compression is not only in the image wise, it also can be in video and also audio. Okay, so because all this all the multimedia is always related to human, no matter audio, image file or video file, it is always back to human. I mean, interact is meant to be interact with human being. So whatever we try to retain would be the important information, which is at least important to human. Okay, as I mentioned before, in one image, as a human, we cannot really identify the high frequency informations, but we can easily describe the low frequency information. So that is why when we must compress sort of image, we will remove the high frequency information instead of the low frequency information. Okay, maybe you have a doubt here. What is high frequency information? What is low frequency information? It's okay. I will explain this one later on in maybe chapter 5. But nonetheless, high frequency information is referring to the the great details. For example, a sharp line on a sharp line across the boundary of the object. You can actually assume that an apple with HD, you can see the water droplet dripping or dripping over the apples, the shiny surface of the apple. Everything is very high definition. But on the other hand, you have an apple which is very very low resolution, and the edge is very blur. You can't even see the texture or the reflection of the sunlight on the apple itself. So when we compare all these, the high definition, the high contrast, the clear boundary is the result of high frequency information. So when you remove the high frequency information, it's supposed to remove all these all these great details in your image. Okay, so this is a difference between high and low frequency information. And what is low frequency information? Low frequency information are the core message of the entire image. For example, you have an apple in an image. So if you remove the low frequency information, you can only see the details, but you cannot see uh, the message in a whole. For example, you have a great apple. You have a you have apple. If you remove the high frequency informations, you will still able to see an apple, but perhaps this apple is a bit blurred. But if you remove, this is the original image. If you remove the low frequency information, perhaps you can only see the details of an apple. Okay. When you remove the high frequency information, you're still able to describe, oh, this is an image with an apple inside. But perhaps the resolution is not so good lah. But you still can understand the message which is carried by the image. But when you have removed the low frequency information, the majority of the message carried by the image would be removed. But all those high frequency information, for example, the details, the shading of the background would be remain. So when you look into this image, perhaps you no longer can tell this is an apple. Okay, so this will be the difference. Don't worry about that. I will explain this later on in details in, I think, chapter 5 or 6 for image compressions. Okay, so as I mentioned before, in multimedia, we no matter in image, audio, and also video, we are trying to explore the limitation of human being. Let's say if you cannot, let's say you don't know how to drive a plane, airpad. This is not a good. If you don't know how to drive a submarine, okay. Even eventually you have a submarine and it is illegal for you to drive, then the submarine is actually useless to use lah. Okay, we don't bother about the money first lah. Okay, maybe we can sell it, with money and etc. You don't bother about that first. So if you don't have the license to drive, it is illegal to drive it in your country. So basically, the submarine is useless to use lah. Okay, the same thing here. So since some information is not being understood by our human eye or human ear and etc. So basically, those information is the best candidate to be removed during the image compression or audio compression or video compression. Okay, so that is what is meant here. since human eye is more sensitive towards the Y component than the U and V component, so in order to reduce the video size, the Y component will be encoded with higher resolution, and we try to remove the information from U and V. Why? That is because human eye is more sensitive to Y. So we remain and also encode the information encrypted in Y component with higher resolution, which means we give more bit, okay, more space to encrypt the information for the luminance. But instead, we will try to remove information from U and V to achieve the objective of compressions. Okay. Historically, the terms YUV and Y prime UV were used for a specific analog encoding of color information in television system. YCBCR was used for digital encoding of color information suitable for video and still image conversion and transmission, such as MPEG and JPEG. So MPEG and JPEG are two different standards. MPEG is for video, JPEG is for image. So today, the term YUV is commonly used in the computer industry to describe the file format that are encoded using YCBCR. So Y stands for the luma components or the luminance, the brightness, and UV are the chrominance component, which is referring to the color. So luminance is denoted by Y and luma by Y prime. The prime symbol here is denote the gamma compression, with luminance meaning the physical linear space brightness, while luma is non-linear perception of the brightness. So basically, this one is just to give you an overview, actually what is Y and Y prime, what is the difference, okay? YUV signal are created from RGB. Actually, not only YUV, I mean, the rest also created from the RGB as well. Just that it depends on how the coordinate being shift. You know, just now we have a box, right? You can actually shift it into HSI or HSV or HSL. Okay, so it depends on how you shift this system to another system. Depends on your application. So the conversion formula is given by forming a weighted sum of the R, G, and B. So this is the formula, Y, R, and B. Y is equal to R, G, and B. Then U is equal to this one and this one, okay. Always remember this prime, when we have prime, you will need to normalize it. So this is the constant value, and you multiply by the value of R, G, and B. Make sure you normalize it, and then you will get the Y prime. After you get the Y prime, B minus this one, you will get the U, R minus this one, you will get the V, okay? So again, RGB, R prime, G prime, and B prime is gamma corrected RGB, which is normalized to 0 to 1. For graph pixel, R is equal to, because one is R prime equal to G prime equal to B prime is actually the same. When if you did use MATLAB, you'll know actually in terms of grayscale, it will give you index in 3 different terms, R, G, and B. Just that all these terms is the same value. For example, X, X, and X, or Y, Y, and Y. Just that's all. Okay. Basically, because this one is actually referring to the chart over there. The grayscale from here, this is black, this is white. So this line will be the grayscale. Okay, so that is why when you have R prime, not a must of R prime, maybe R, G, and B all is together, and then you will actually get a grayscale. Okay. The luminance Y prime is equal to the same gray R prime. Since the sum of the coefficient, this is equal to 1. Okay. Actually, this one, and this one is summation is equal to 1. Thus, Y that represent the luminance can be thought of as containing grayscale intensity. U and V carry the coordinates or color informations. Okay, always remember human eye is more sensitive to brightness, which is the luminance or the luma, and the human eye is less sensitive towards the color component. So during the conversion, not conversion, the compression, we will try to remain as, allocate more bits, for the uh, brightness value, but we try to remove more information in terms of the color, more color value. Okay. So this is just actually this is actually the matrix. You just try to move this together and rearrange it so you will get something like this one. Okay. Okay. Actually, how you get it is very simple. You can actually look it uh, slowly. First of all, you have this value, right? So basically, all this value, you just transfer here. You take out the R, G, and B one, B prime, sorry. You put it here. You take out the R, Y prime, U, and V, put it here. And then you continue. You start doing the simple calculation. So you substitute this one using this one. So you will need to remain this one and this one, but you will remove this one. Not remove lah, but some calculation because the coefficient of this B here is 1 ma. This is 1. This is Y. So you replace using this one. The same thing, just a simple calculation. You are able to get this one. Maybe you can try it. Yeah. Oh, I did provide the solution. Okay. This is the equation from here. Here. So you can actually rearrange it. How? So basically, U is equal to B minus Y prime, right? So this one, substitute the Y prime, you will get this one, you will get this one. And the same for V. Just simply V is equivalent to this one, R prime minus Y prime. So substitute the Y prime and you continue the equations, you will get this one. Okay, get this one. And then the coefficients, put it in. This coefficient, put it in here. And this is the original coefficient of Y prime. Okay. So once goes backward from Y prime UV to R prime, G prime, and B prime by inverting the matrix. Okay. This is the common mathematics. Inversions and the A and A minus 1, something like that. Okay. To obtain the grayscale image, simply convert each RGB pixel to a YUV or YIQ pixel and keep its luminance channel and discard its IQ chrominance channel. Why? Because the luminance channel here would be the Y. The chrominance channel would be either UV or IQ. Okay. Remember, luminance is about brightness. and this is about color component. Okay, since you convert to grayscale, you don't have any color component, right? So basically, you just remove this one, which means you remove U and V lah, and you remain the brightness, which is a Y. Okay, so yeah, that is how you actually convert lah. I mean, if you let's say you have a grayscale and you want, I mean, if you have a RGB in YUV or YIQ, basically from, I should put it in this way. Basically, you just remove this one, so you will get the grayscale. Okay, when you convert YUV or YIQ to grayscale, it just I mean, excluding the color component will do. So here is the example. This is the original color image. This is the Y channel, U channel, and V channel. So as you can see, the Y channel is likely to be the grayscale, the grayscale of the original color image. But instead, U and V is like a bit different from what you understand. This is just an example, lah. I mean, if you ask me why UV is like that, it's based on the equation as well. And if you say, what is the benefit of changing to YU and V? Of course, it is relevant to your application. With different applications, you have different uh, priority, which color model is best to use, and etc. And of course, when it comes to video, we are more, I mean, we put more priority on the televisions. And when you come to televisions, you have to comply to certain standard. When you have certain standard, you have to check what electric supply you have, what is the uh, standard of the region of not company region of the country you are. So with different region, you have to comply to different standard. So that is why you have YUV, YIQ, and etc. Eventually YCBCR. Okay. So YIQ is used in National Television System Committee, NTSC color TV broadcasting. So again, gray pixel generate IQ and chrominance signal. Gray zero. Oh, okay. Gray pixel generate zero IQ chrominance signal, which means in gray pixel you don't have Y, you don't have IQ, you only have Y. Okay, which means zero lah. Although U and V are nicely defined, they do not best correspond to actual color sensitive of human eye. In NTSC, I and Q are used instead. This is because different standard, so they prefer to use different color model. Instead of the YUV, they use YIQ. YIQ is just the inversions, it's just a version of YUV with the same Y, but U and V are rotated by 33 degrees. This leads to a formula matrix form, this one, okay, just with a rotation of the 33 degrees. So when you have YUV, this is the result. Yeah, YUV, this is the result. Basically, you can calculate this one using your MATLAB. You can try using your MATLAB, insert a color image, and then you convert to different color model, YCBCR, LAB, maybe HSI, HSV, different color you can play around using MATLAB. Okay, it's easier, I would say. And YCBCR is another standard, which is REC 601 standard for digital video, uses another color space, which is YCBCR lah, this one. Model is closely related to YUV transform. This makes the equation CB is equal to B prime minus Y prime divided by 1.772 plus 0.5. And CR is actually R prime minus Y prime. And the divided by 1.402 plus 0.5. Actually, although in this chapter, you have several different conversion, from CMY. I think the most simple would be CMY to RGB lah. That one is just 111 minus by your CMY model. That's all. And for you, YIQ, YUV, the conversions, don't worry about that. Let's say it's appear in your examinations. I believe the formula would be given. Okay. Because I'm I don't really into asking you to memorize the formula, which is not common. Of course, when it comes to some commons like Ohm's law, like radians formula, you have to know lah. But for this one, I think don't need lah. Okay, because I would like to prepare you all for more on reasoning rather than memorizing the formula. That is not what's supposed to be learned. Okay, you're supposed to know. You're supposed to know. There are equations to convert between YCBCR and also RGB, to convert between RGB and YUV and etc. But then I don't think it's necessary for you to memorize. Even though you memorize it, it is just to take the exam. I don't think it's really benefit your future. Okay, so that is my opinion. So if in case all this kind of conversion is, appear in your exam, I will put it in the examinations sheet over there. Okay, so I think you don't need to memorize all this. Okay, but of course, again, those common one like this one, like the common one, I wouldn't give you lah. Okay, or only will provide those which is very complex. All right. So any questions? I think yeah, that's all for chapter 3. Yeah. Any questions from you all? No, okay. Remember later on we have tutorial 4:30 to 5:30, 1 hour. All of you have to join because we have combined class. Okay, all of you have to join. And yeah, that's all. See you all later on 4:30. If no questions, so that's all for today. Thank you. Bye bye.